In this video, we'll generate the dataset and the Taylor Maclaurin series expansion of SINE function and its expansion coefficients and the regression coefficients. We'll also show the trend line and trend line equation of the SINE function. We begin with the dataset. So array formula, SINE of the x values. And we show the chart, the trend line and the trend line equation. We use scatter chart and generate a trend line raised to the power or to the degree 8, polynomial to the degree 8, and use the equation as label and relocate the title to the bottom. So the label will be at the bottom for easy comparison with the polynomial regression. So here we have the trendline equation, polynomial to the 8th degree. We have B0, B1, B2, B3, B4, B5, B6, B7, and B8. We calculate these values using LINEST. Next, we generate the Taylor Maclaurin SERIESSUM of the SINE function, where it is equal to the summation of a times x to the power 2n plus 1, where coefficient a is equal to negative 1 to the power n over factorial 2n plus 1. And the values of n will be 0 to infinity. In this case, we can reach up to a maximum 13. Next, we generate the Taylor Maclaurin series sum. So array formula, series sum of the x values raised to the power starting from 2 times 0 plus 1. So starting from 1. And the increment. 2 times 1 plus 1, that's 3. 2 times 2 plus 1, 5. So 1, 3, 5, 7, 9. So the increment is 2. And the coefficients will be this range. And we'll show the equation as well. So edit chart, series, trend line, polynomial to the 8th degree. And show the equation as labeled. So here we have the equation. We can continue with the coefficients. So it is equal to array formula minus 1 to the power n. That's the numerator. Now we can continue with the denominator, which is factorial 2 times n plus 1. So let's factorial 2n plus 1. Enter. The values match, well, almost match up to here. Up to here, they perfectly match. But as you go farther, there's a bit of an error. But in the trend line, they're all in the same trend line. And their regression coefficients match. So B0, they match B1, B2, B3, B4, B5, B6, B7, they also match, B8, they all match. We'll now calculate these values, the regression coefficients, using LINEST. To do that, we complete the 1, x matrix. Here you have the 0 degree of freedom because the number of rows equals the number of columns. So we begin with the power. So R, that's transpose of this. So we have 8 columns and 8 rows. That means there's no That's 0 degree of freedom. To complete the 1 comma x matrix, we have array formula of the x values raised to the power 0 to 8. Now that we have the 1 comma x matrix, we can calculate the LINEST. LINEST for the function itself, data y, and data x. So here you have the coefficient, regression coefficients. For the Taylor Maclaurin SERIESSUM expansion, we have also LINEST, data y, and data x. That's the regression coefficients. Our regression coefficients, so the B0 and we have A0, they don't match. And B1, A1 does not match to B1. So most likely this is the B1 and this B this could be A1, A2 because they do match, but A3 they are really far away. So let's compare it with the trend line. Our B0 they match because negative 1.16 to the power negative 29, that's already 0. B1 1.07 is match. B2 negative 0.194, it also matches. B3 negative 0.0433, oh no, this is 0.0433, they match. B4 negative 0.1194, that's rounded off. B5 4.74, or that's 4.74 times 10 to the minus 2. And B6, that's 7.83 times 10 to the minus 3. B7, 5.14 times 10 to the minus 7. And B8, negative 1.334 times 10 to the minus 5. This completes the use of array formula to generate the SINE function, the series sum to generate the Taylor Maclaurin series expansion, and LINEST to generate the polynomial regression of the SINE function.